The ACM Turing Award, the Nobel Prize of Computer Science, went to Professor Rich Sutton of the University of Alberta, Canada in 2024. But the reason AI researchers worldwide talk about Sutton today isn't the Turing Award. It's a roughly 1,000-word essay he posted on his personal blog on March 13, 2019, called The Bitter Lesson. The claim was striking. Looking back at 70 years of AI research, methods that incorporate human knowledge have always lost, and by a wide margin, to general methods that scale computation. To understand this claim, we need to look back at 70 years of AI history. In 1972, Stanford University developed MYCIN, a medical diagnosis system that used about 600 if-then rules to match the diagnostic accuracy of physicians. The Psych project, started in 1984, tried to encode all of human common sense as rules, and still wasn't finished 30 years later. Then deep learning arrived, and these systems became obsolete. At the 2012 ImageNet competition, AlexNet achieved a top 5 error rate of 15.3% versus 26.2% for traditional methods, a gap of more than 10 points that ended the era of handcrafted features. The same pattern has repeated across chess, speech recognition, and computer vision. The examples Sutton finds most compelling are chess and Go. In May 1997, IBM's Deep Blue defeated world champion Garry Kasparov 3.5 to 2.5, but it relied on roughly 8,000 hand-coded chess-specific evaluation rules. AlphaZero in 2017 was given only the rules of the game and learned through self-play, beating the top engine Stockfish with a record of 28 wins, 0 losses, and 12 draws. In Go, AlphaGo defeated world top player Lee Sedol 4-1 in March 2016, conquering a domain once considered beyond AI for at least another 20 years. Its successor, AlphaGo Zero, used no human game records at all, just 4.9 million self-play games over 3 days, to beat the original AlphaGo 100-0. Let's understand Sutton's argument precisely. The paper opens with, "The biggest lesson that can be read from 70 years of AI research is that general methods that leverage computation are ultimately the most effective, and by a large margin. The two methods that scale, according to Sutton, are search and learning. These scale with improvements in computing power, without limit. By contrast, hard-coding human knowledge doesn't scale, because there's a biological limit to how fast humans can encode knowledge." Sutton calls this lesson bitter because researchers' pride in their own expertise has unconsciously blocked the path to better solutions. The era of large language models began the year after The Bitter Lesson was published. In January 2020, Jared Kaplan and colleagues at OpenAI released their Scaling Laws paper, testing more than 200 models across 7 orders of magnitude of compute and demonstrating that loss improves with scale according to power laws. GPT-3, released in June 2020 with 175 billion parameters trained on 570 gigabytes of text, generated human-level prose using raw computation with no linguistic rules. In December, AlphaFold 2 solved the protein folding problem, unsolved since 1972, achieving a median GDT score above 90 at CASP14, compared to 75 for the runner-up. The Bitter Lesson's predictions were coming true, one after another. These results emboldened supporters. OpenAI co-founder Ilya Sutskever repeatedly cited this paper as the theoretical foundation for their scaling strategy. Kaplan's Scaling Laws paper justified the bigger and stronger roadmap from GPT-3 to GPT-4 to GPT-5, and gave AI companies grounds to pour hundreds of billions into computing infrastructure. In 2024, a study presented at CVPR, the world's largest computer vision conference, analyzed 20 years of papers in the field and found that papers with higher alignment to bitter lesson principles had a statistically significant positive correlation with citation counts. The idea that scale is the answer became the mainstream position in the industry. But the pushback was persistent. MIT's Rodney Brooks published A Better Lesson in March 2019, the same month as Sutton's essay. He raised 6 objections to scaling, including, CNNs already encode human knowledge like translation invariants, and self-driving cars need 2,500 watts of compute while the human brain runs on 20. NYU's Gary Marcus called it a weak inductive argument, while Meta's chief AI scientist Yann LeCun argued that statistical prediction without a world model has structural limits and proposed an alternative architecture called JEPA in 2022. A 2022 survey of NLP researchers found that only 17% agreed with the strong scaling hypothesis. The most remarkable development came in 2025, when Sutton himself changed his position. On the Dwarkesh podcast and elsewhere, he declared that LLMs are a dead end. He argued that LLMs are imitation learning on human text and lack the ability to learn continuously from experience. This echoed exactly the criticisms that Marcus and LeCun had been making for years. Marcus posted on X almost immediately, "Mr. Bitter Lesson, Richard Sutton, now sounds exactly like me." The very LLMs that had been used to vindicate the bitter lesson were now being called a dead end by their greatest advocate. That's what people mean when they call this the bitter lesson about the bitter lesson. The bitter lesson leaves us with a simple question: are we still making the same mistake? Is our pride in our own expertise unconsciously blocking the path to more general solutions? And just as Sutton himself came to acknowledge the limits of LLMs, today's right answer may itself be rewritten tomorrow. The bitter lesson learned over 70 years may itself be a lesson that will one day be rewritten.